So, hello everyone, and thanks for coming and staying after a long, hard day of FOSDEM. So this talk will be about a kind of software ecosystem with various different small graphical software, mostly for art creation, so interactive music, art show, installations, museums, this kind of stuff. And I will first start with a small video, which is of an installation that took place in France last year. So the voiceover is in French, but it's not really relevant. It's, for instance, it's a big carousel. I'm sorry? Oh. You're up? Okay. And so, for instance, in this installation, people were playing musical instruments that were all synchronized together, and in order to make a song. So this is the kind of work that we are trying to make, and make tools that allow such things to exist. With, like, there were 23 instruments. Well, here we have the overall thing with a big computer at the center that makes everything run, various MIDI devices, various sensors, so everything coming in, light shows, and how to synchronize all of this, how to make it work, how to make nice shows. So, yeah, so basically what I said. And of course, this is free software, which is cross-platform as much as possible. The main software is built with Qt, and then there's a lot of libraries which only depend on standard C++ and nothing else. And it works with a lot of various environments, so pure data, for2to processing, open frameworks, Unity, 3D, quite a bunch. So the first thing I will present is libossia, which is the basic C++ library that will allow to define basically what we want to do. So libossia is a distributed object model. That is, it has objects on various software which communicate through the network to, well, make everything work. So one computer can tell another computer, increase the volume, set the light to red, whatever. And the particularity of libossia is that it has been ported to a bunch of these environments. So maybe it's too small here, but so Java, processing, pure data, Max, well. And it is based on open sound control. So for those who don't know open sound control, it was touted as a replacement to MIDI, which is the standard for devices such as this, which send notes and play sounds. And open sound control is much more general, and as such, we based ourselves on it. So, and I will make a few demonstrations of the various possibilities of libossia. So I will start with a pure data patch. So I don't know if any of you know pure data. Does it work? Okay, looks great. Okay, so this is pure data, and so pure data is basically a fairly old software nowadays, and where you just put boxes on the screen and you draw cables between the box, and this makes sound. So we have a set of objects in pure data that you can use to create, basically, to give names to the parameters that you are going to control. That is, for instance, but again, it's very small and sits in some old software made in CLTK. There's no way to zoom, so I'm sorry. But basically, you can control notes and things like this, and do, for instance, some triggers up like this, and toggle. Yep. So, for instance, you draw cables like this, and you will hear very beautiful music, hopefully. Actually, it's pretty terrible, but it's to give a simple example. And so in this pure data patch, we basically define a set of parameters, so like gain, frequency, stuff like this. And the point of ossia is to make these parameters accessible to any other software or hardware. And as such, we use multiple protocols. So, for instance, we can use QML applications, which will, well, allow to control the patch. Okay, if it works at least, but it doesn't. Huh. Great. Fantastic demo effect. I think that the Wi-Fi killed my test. Okay. Great. Firefox. Okay, let's see with the HTML example. Okay, so here I have an HTML web page where I can control the parameters of my pure data patch. So here we can see, for instance, if you look, this part will change when I change this slider. And so that's a very strong point when we compare to previous solutions, which required some kind of OSC bridges, like with Node.js, between the media application and the HTML web page. So nowadays, you can basically control a lot of such applications directly from a web page or a lot of other things. And so, yeah, just to look at another example. So we can look at the QML example. So QML is language for graphical interfaces. And where is it? Hey, too many windows. Sorry for the noise. Okay, my computer is hating me apparently. Because okay, a simple text editor won't start, so I don't know what to do. Well, okay. So these are just slides for people who are not here so that they can see basically what happens. And yeah, so in terms of interoperability, I already came here 3 years ago to make a presentation with another protocol which was called Minuit and which was entirely based on OSI. So OSI is nice in that it only requires UDP, but in some case UDP is not enough when you need reliability, when you need, for instance, to send a lot of messages in a small amount of time. It may not be most efficient. So with multiple companies, we tried to find alternatives, and so we worked for this new protocol called OSI Query, which adds a query layer with WebSockets and JSON on top of OSI. And so we're a lot who made many different implementations, which all work with the original OSI stuff. And you can find here the specification. So yeah. So to give an example of the software that are compatible with OSI queries, so there is, for instance, VDMX, which is fairly used video mapping software, and VJ. Vezer, which is an OSI timeline, so you can send OSI message in time. And Millimin, which is specifically made for video mapping and so projecting video projections and stuff like this. So all this software generally don't work on their own. They require communication with other software. And up to now, the question was how to make this communication work reliably. And well, the answer was this protocol. So yeah, what I said, JSON over WebSockets. It supports WebSockets directly and has various features that I can show in a web browser. So here, here, for instance, I am connecting to the pure data patch, which is making these adorable little buzzes. And I can see, thanks to Firefox's ability to display JSON neatly, all the parameters of my patch. So for instance, I have a, say, modulation ratio, which is a floating point value, the current node, which is two floating point values, and currently 38. And so this kind of stuff. Yeah, the gain, which is interesting, it's in decibels. So there is a unit system. You can say, okay, this is in decibels, this is RGB colors, this is region and polar positioning. So you can add a lot of metadata to your objects, which allow the software to make interesting choices. For instance, if you have an RGB color, you can send it HSV values, which will, of course, convert into the correct color spaces. So this is basically the general idea of libossia. And on top of OSI, it also adds some kind of publish and subscribe mechanism, which allows to say, okay, I just want to listen to one or two addresses amongst all the possible addresses that are available. And the interesting thing is that all the current implementations work with zeroconf, so it just works basically. You see all the available devices and you connect to it. So next, I will move on to another small example. If I can kill everything, that is okay. So this next example will be less sonic and more graphical. So if you don't know processing, it's a graphical, well, it's a textual language based on Java, which allows to make nice visuals very easily. So here I took a simple example that comes by default with processing, so credit to its author, David Pena. And I've modified it to add libossia bindings. So here, for instance, I don't know. Can you read the text here, or is it too hard? Okay. Okay. And so, for instance, the API looks like create a node which is called weight, which is a float, and set it between 0 and 50. So again, if we go to a web browser, okay, so it's not the same IP. 5, 6, 2, 8. Okay, so here we will see the nodes that we created in Java, and well, basically it's the same thing. And the question arises, what happens when you have like multiple applications like this, like the one which made sound and the one which makes graphics, and how do you control them when you have a lot of them? So generally you make what is called control surfaces. And okay, example 2. Yeah. Here there is a software which is called which is fantastic. The Wi-Fi is basically preventing my stuff to work for some reason. Okay, fantastic. Okay, just restart. Stop. Stop. Okay, well, that's the best demonstration effect I ever had. Okay, cool. Let's see what did go wrong. Sorry for the annoying thing. Add device. Okay, so apparently I have some network interferences, and since everything is working through the network.
Are you using broadcast?
No, not at all. But it's using Avahi, and I don't know, like Avahi didn't like that I connected to the local Wi-Fi apparently, so. I'm sorry? Avahi is not? Yeah. Yeah. Oh, it's blocked on the local network? Oh, okay, so thanks for the explanation. Okay. Just restart the network, and Okay, goodbye. No, 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 no. Yes. Okay. No, it can't see them at all. And I'm saying this device Wi-Fi delete. Okay. Well. Okay, I'll just move on without the example, I think. Okay. Sorry for the noise. Okay. Well, I just move on like this. So the idea is to have this kind of graphical stuff with parameters that you can control. And well, the problem is if you want, to map these parameters with, say, to control them. If it's only code like this, you don't have any kind of graphical interface. So you have to control them by outside. And so we have a remote software which can see automatically when Bonjour works over the network what is available, and you can just basically drag and drop all the parameters, and they will show up as the correct parameters. That is, if it's a float, it will show a slider. If it's a Boolean, it will show as a toggle, these kind of things. And then you can, of course, have multiple devices in the same environment. So this is the remote, which is also free software and available on the ossia repository. And then there is the main meat of the thing, which is ossia score. And okay, I just stop network manager. And I just try to stop the network to see what it gives. Okay. So here, I don't have any kind of local host. Okay. And okay. Reconnect. So okay, I don't even have a local host working, so do you mind if I reboot my computer, because I think like there's something which is seriously went wrong at some. Okay, it's the HDMI cable which. Yeah, it's a HDMI cable which did that sound. So yeah, that's fairly weird. Yeah, just so best presentation ever.
Oh, you showed us. It's a lot of work to get it right.
I'm sorry?
You show us that it's a lot of work to get it right. So
Well, yeah, and I spent a lot of time today making sure that it will work right now and rehearsing my demos. So yeah. Okay, so there should be okay. And stop CD demo FOSDEM CD3. Okay. 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 And yeah. Okay, I don't know why, but the most basic IP address doesn't work, so, well, I just move on and cd duck cd. Okay. So, yeah. So, ossia score. So basically, when I came here like 3 years ago, and I had this slide, and well, it changed quite a bit since, because basically the main difference since then is that we added an audio engine to the software. So while it used to only send OSC messages to the outside world, now it only it also supports sound playback, so it can be used by musicians and stuff like this. And the formal model is based on directed acyclic graphs, so like your data, like Max, and like a lot of software that hide it behind a nice user interface. So, and sound, and I will just stop trying to make my original demos work and just make mine on the fly, because of course that will work fine. Build. Okay, so this is how the software looks. So there are 3 parts to the user interface. One is the remote devices, like MIDI devices, OSC devices, this kind of thing. One is the score, so basically where you write the progression in time of your objects. And one is the inspector, that is what kind of object are we seeing. So for instance, this is a small dot which just says that there is something at that point in the timeline. And this is the way to say, okay, something will happen for 5 seconds, more or less. So if any of you know usual sequencers, well, it works mostly the same. And yeah, up. So basically, the big difference since older version is that nowadays you can go into music. Yeah. Okay, say this for instance, and have a nice sound. Okay. Okay, I'm sure you all heard that. Woo. Yeah, so since the screen is crowded, I'll just move this. Yeah. Okay, so tada, it works, finally. So the big difference between iScore and other sequencers is that you can say that things will depend not only on a fixed time, but on various events that can happen. So for instance, here I can say, okay, this sound will last until something happens, and then we move on to something else. So here, if you can see, it continues because I clicked here and it told it, okay, stop here and continue, which is fairly useful in show situations. For instance, if you have dancers that are too fast and there is a fixed soundtrack, well, you can say, okay, this part will move on a bit faster than the rest. And so there is this main feature. And another very important thing is conditions. So you can say, for instance, a part will run like this. Okay, and yeah, let's move on. According to a condition, that is, if something is true, if someone, well, pressed the button, then we can move on to the next part. Else, we won't play it at all. So, up. For instance, I can say, just for the sake of the example, that it will never be true. And these parts won't execute at all, which is basically standard logic. So it's a if condition, but which is graphical. So there's a whole visual language that has been made for the sake of the software, and which can be used to determine various outcomes in musical scores, in this kind of stuff. So, and another new thing is the support for FOSD. So I don't know if any of you know FOSD. Okay, so FOSD is a programming language that was developed at Grenoble in France by the GRAM, and which is especially made for high performance sound, basically. So I may have some example online. Yeah. So FOSD code looks like this. So this is based on functional languages. So you basically combine operators, and it's very close from point-free programming, if you know what that is. And so you can easily write sound algorithms that will perform very efficiently, because FOSD comes with a compiler that leverages LLVM to produce fairly optimal native code for your current CPU. So, for instance, in Score, we can say, okay, I have my preset library with various FOSD sounds, and I can take, say, Plus, yeah, this one is nice. Okay, up, no, no, okay. Okay, so, and at this point, for instance, I am going to play an instrument, and of course, I want to keep playing it, so I will just say, don't go, well, keep waiting until I tell you to stop playing. So, when I'm here, and great. Okay, that's the. Okay. Well, we hear it just a bit. Yeah. Okay. Well, that's fairly subtle, I'm sorry. But basically, yeah, it's like VST plugins, but they are compiled for your specific CPU model and architecture when you add them. So it's quite resource efficient if you need to have a lot. And it also works on so many architectures like ARM and x86 and, well, all kind of stuff. So, for instance, I can also take my original crash sound and added some kind of reverb. So yeah, there is reverb. And here I will say, okay, let's take the output of my crash sound and wire it to the input of the reverb. So this looks pretty much like pure data. And okay. So yeah. So I don't know if you hear the sound of the crash filling more and more. And I will just now keep the reverb sound. Yep. Okay. So here we only have the reverb part of the sound, and so I will just kill this small synthesizer here. Okay, goodbye. So yeah, so these are the main new features in Score, which are basically sound processing and a graph of values. So I will try to see if I can have something that works with I think that this is wrong also. So, processing. So it's processing that makes that weird noise. Okay, so this is my processing patch, and can I see it? I would really like to see it on device. Okay, so things start working, so I don't know what I restarted, but okay. And okay, and no. So it doesn't actually seize it, and okay. This is fairly distressing. Well, okay, localhost maybe. Okay. Well, no processing then. Great. Okay. Well, I can still send it manually. OSC addresses. So we just heard the ending of the reverb cue. 5628, I think. Yep. So even if this doesn't work, we can still do it basically with the old OSC way, which is sending parameters directly to the OSC port. 1, 2, 6, 7. Okay. And there you can say, okay, I want to create a new OSC address, which we will call wait because that's its name here. And child, okay, wait, float, which will be between 1 and 200. So this is all the part that we have to do manually because the other protocol apparently doesn't want to work today. So where is the big thing? Okay, so the sphere is here, and if everything works correctly, 8. Okay, so this works, and I can send OSC messages like this to well control the weight of my processing thing, and I can say, okay, after this sound, let's take this weight, and it will go from let's say 0 to 200, and okay, let's move on. And here we have simple automation which runs and does some kind of nice flower, and yeah. So this is the first thing that we can do. But we can also, for instance, try to map sound parameters to well the controls. So, for instance, we can say at some point we will start playing a drum loop. So I will add a loop, and in that loop we will play a sound. So I will just need to find a sound to play in a loop, so maybe not a snare because you will hate me. Yeah, small hat, for instance. Yeah. Okay, so this should be quite short. So here you will see that so here we just play a small thing, and basically this allows to do stuff just like most looping environments, because you can end up with the same kind of behaviors that you have in live, with multiple loops that are all synchronized together and this kind of stuff. But I don't have time to build them. So we want our loop to keep running. And actually, I think that I have some better drum loops than this one. Okay. Yeah, drum 12. Okay, this one is much better. And we will use the sound of the drum loop to change the graphical object. So, and we want this to last like 3 seconds. And okay, so this is a fairly basic drum loop. And now we'll say, okay, let's take the amplitude of that sound. So like this, library, process, audio, envelope. So we take the output of our sound, we put it in a plugin which will compute, the root mean square and the peak volume of the sound wave, and we will say, okay, this will actually control this parameter. So I can just say, okay, the weight goes here, up, and we will And here it disappears. Why? Because the envelope of the sound is fairly small, and we need actually to make it, well, to multiply by some value to get something that shows up on screen. So instead, we will first add something that allows us to do some computations. So, yeah, I went too far. Envelope and custom mapping. Okay. And I take the output of my first sound here and the output here. And here we can basically do some inline computations of various kind of mathematical formulas. So I can just say 10 plus x times 100, which will just, well, apply the formula. And it also uses a fairly optimal basic, how to say, engine, mathematical engine, which does just-in-time compilation of the formula. So it's quite efficient, actually. And I will just wait. Okay. Okay, and here it's much smaller. I really need to multiply it by much more than 100, actually, it seems. So 1,000. 1,000, we start to see stuff happening. And 10,000. And 10,000, it actually starts looking like a Otaker visual clips. Well, just a bit. And okay. So, and the thing, so as you could see, and this is also something that didn't work 3 years ago, is that you can basically edit everything while it's running and it doesn't crash, which was not always true. Okay, and so you can do this, and you can also, since we have this kind of things, we can also control the colors. So for instance, I can say, okay, let's make a color gradient like this. So automation color. Okay, and we will add another node for the color of the processing thing, and child color, I think it's called, which is vec4, and we will set it as a ARGB color. I think, I'm not sure of the actual unit used by processing, but okay, okay. So yeah, it's not ARGB, it must be RGB8 maybe. RGB8. Okay. Okay. So I don't know if you see the color changing a bit of the. Yeah, maybe I should set it to another color to make it more visible. Okay. It actually doesn't work. Great. It's certainly not the right name. Okay. ARGB edit ARGB8. So some software work between 0 and 1 for colors, and some others work between 0 and 255, and I don't remember which is which. So yeah, fantastic. Just check the processing code. Yeah, I don't have it. Okay. Well, okay. What else to show? So basically, so this is a three-part inspector. So you can see the user library with some things contributed by the user software, and the internal capabilities, which are all of this. So for instance, another useful stuff for art is step sequencers. So like this. So here, for instance, it will start doing sequences on the previous parameter up until I say it to stop, and we have to tell it that it has to be, for instance, between 0 and 300. Okay, and here you see that the weight changes basically. Okay, and then it moved on to the next part, so I have to start again. Okay, so basically like this, and it can change fairly quickly. Let's say like this, for instance. Yeah. Okay, so for instance, stuff like this. And well, it will just make some kind of nice motion and things like this. And so the last thing that I wanted to show, so this was basically previous example. So first we did it, this current example, and the last one is another example, but which won't work because of the network issues, which is a video player, which is also available through OSI query, and which use MPV for playback, which allows to play fairly smoothly a lot of HAP videos. So do you know the HAP codec, anyone? Okay, so for those who don't, HAP is a codec which basically use GPU frames encoded, so it basically can very easily be scrubbed because it really doesn't need to do any decompression. It's a video card which does the decompression. And I can just show you what it looks like. Oh, FOSDEM. So video player, and for instance, I can launch 5 instances, and it will play back 5. So these are 720p videos, and they are all GPU decoded, and well, can be controlled over the network. So they can be scrubbed. So yeah, the big interest of HAP is that you can basically scrub extremely easily. So there is no delay when you tell it to scrub. It just goes at the right frame, unlike like X264 or 5, which have some time of decoding because it has all this B frame problem, which you don't have with HAP. Every frame is a full frame. So and again, so like earlier, we've worked with the VDMX guys who also made the HAP codec, and well, to get it to work. So yeah, and it should have looked like that with score, which controls multiple videos and tells them to scrub at various moments in time. So, and for the remaining things, we miss scripting with LLVM. So there is an ongoing extension on internet. Do I have internet now? GitHub. Yeah. Score and done JIT. So a plugin which basically, so most of the software is written in C++, and right now we make releases that are well targeting the baseline computer of our users. With this, we can also use LLVM, which we already use for FOST, to basically compile at runtime some of the execution part of our engine to make it more performant on the user's machine, and allow easily to distribute add-ons. So you just send the source code on the user's machine, and it compiles the C++ code and executes it immediately. So this currently works on Linux, but not really yet on Mac and Windows. They're almost there. So the video playback currently is out of process, so we'd like to move it in process and have more powerful shader capabilities on it, so like transforms and, if possible, combining multiple videos. There is a work in progress port to WebAssembly, so the main user interface is able currently to start, but the execution still fails because due to the Spectre mitigations last year, all browsers have disabled WebAssembly threads, and well, threads are currently needed to make it work, so we are stuck at this point. And fix them bugs like today. Okay, now I know that there can be nice network problems. and all the links. So of course everything is open source, and well, you can just grab and well take it. So it's on Mac, Windows, and Linux. So yeah, and there have been quite a lot of artistic installations done with it up to today. So and the carousel. So I also would like to thank Pascal Balthazar, who is the main user of the software and who did a lot of bug reports. Pierre Cochard, and there isn't his name, but Thibaut Keller. So there's a community of users who keep making artwork with it and making bug reports and sometimes even contributing code. Antoine Villeray, who made the pure data port. So yeah, some people are working on making this actually usable for installations, and well, multiple things out there in the wild run using ossia score. So maybe you've seen some, I don't know, but yeah, that's the overall thing. So thanks, and I'm really sorry of all the technical problems. It sucks. So thanks everyone. And
Are there any questions? No question at all? No second thought?
I too want to take a small beer too.
We have one question. I'm coming, but slowly.
Hi, thanks for your presentation. Perhaps because of all the network problems, perhaps you can elaborate a bit more about how it works.
Yeah. Well, it should work simply. That is, libossia basically creates a WebSocket server in the application, and so there are two parts. There is the zeroconf part, bonjour, which doesn't use TCP and UDP. It really passes through DNS requests, which is a whole kind of form. And once this is done, well, there is a simple WebSocket connection. Once the connection is established, we receive the same JSON blob that there was, for instance, here. We can see the video one, which, okay, no. I'll just check. Well, okay, so like we saw earlier, we just get a big JSON blob, and then we create on our side the OSC namespace, basically. So yeah, that's all there is to it.
And what do we need to do to integrate it?
Well, mostly, so there are a lot of examples on the website. So I'll just show you the simple C example, for instance. So the library itself is written in, I'd say, postmodern C++. But you have a C API if you want to make it work in other environments. So for instance, you can go to documentations.
What are the dependencies?
Only the library. It's a pure.
No, I mean the library itself, like the C example you just showed. What does it depend on?
Yeah, it depends on the library, but you can also implement it yourself. But we found out that in the end you need OSE client and server and WebSocket client and server. So
exactly.
Yeah. So a simple C example, for instance, which would expose a few nodes over the network. No. Okay, I don't know why it wants to. So no, this is a C++ example. It's not the one I wanted. Documentation, tutorial, C. So there are a few, the same thing made multiple times. So yes, this one is pure C.
Yeah.
And you just, say, I want to create a server. I will create nodes in this server, which will be, for instance, of type float, which will have the value 344. And then you can just, from your server, continue to push values. So it really works like many OSC software. And on the other hand, you also have all the client API, which is, I want to connect to this device, which is at this address, WebSocket, localhost, blah, blah, blah. And you will automatically here get all the parameters of the client. So at this point, you can just say, okay, I want to find the original node, and well, maybe the connection didn't work and you don't have it, but if it did work, well, you can be assured that you have the same, it's a mirror of what exists on the server, basically. So yeah, it really makes a copy of it, and then you can push on the other software, and it will send the value to the original one. And an interesting feature is that you can choose if you want for your parameters to be sent through UDP through OSC or through TCP. So for instance, if you have a, say, play message that starts a video, you really don't want it to be lost due to UDP packets getting lost, because it always happens. So you can say, okay, this one, I want it to, it's safety critical, I want it to always go through TCP, because at least I know that if I have some kind of internet connection, it will get through. So yeah, that's mostly the gist of it. Yeah, in terms of conceptual model, it's just a tree of parameters with properties and.
All right. And so if I implement this in my own application, then it will show up in this this score application.
Yeah, in score and also in all the others that I've shown in the slides.
Yeah.
So for instance, it will show up in Vizer, which is fairly similar to score. VDMX, they all support the protocol and they will all see it. So we spent a lot of time with these companies making sure that interoperability worked fine. So
Yeah. But I was wondering about the GUI application, because it looks amazing.
Which one?
The score application you were demonstrating.
Oh yeah.
However, it seems you're talking about an interactive installation, and the application seems time-based.
Oh yeah, but there's a small trick, which is just that if you want to make an installation, so here, for instance, we have a timeline, so like Cubase or whatever, but this is not a necessity at all, and we can instead have a loop, so process and structure and loop. Okay, view inspector. Okay. Loop. Here we go. And here, for instance, it will just keep running forever, basically. No, not like this. Yeah. Like this, and here I will just set a small duration, and for instance, if I do this, okay. Okay, I've lost audio, it seems. Okay, this works, and yeah. So here, it will just keep doing the same thing over and over again. So if your installation basically needs to keep running, you just do this, and well, it has its loop logic basically in here, because that's how you will do it in C. For instance, you just make a big loop while we can receive events, then we process events, and that's really the same thing, but it's graphical basically. So yeah, that's how you will do installations, and yeah, that it works.
Yeah, nice. Thanks.
Okay, well, thanks you.
Any other question? No.
Okay.
Well, thank you, Jean-Michel.
Thanks everyone.
And thank you everyone for the dev room.
Yep.